to prove sine A theta or cos A theta is equal to something. The second type, like that would be like they'd ask to say sine 3 theta is equal to something. The second type is where they look for sine cubed theta. But in this one they look for sine A theta or cos A theta. They will ask you to show something like sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. Is that alright? So they might ask you to prove that identity. If it's a sine A theta or a cos A theta, this is the process. Because it's 3 theta, you will say cosine theta plus iota sine theta to be cubed is equal to cos 3 theta plus iota sine 3 theta. That's by using the Moivre's theorem. We good to go there? But I could also say cosine theta plus iota sine theta to be cubed is equal to 1 plus 3 plus 3 plus 1 by Pascal's triangle. You got that? And by Pascal's triangle, that's cos cubed theta, cos squared theta, cosine theta. Iota cubed sine cubed theta, iota squared sine squared theta, iota sine theta. That's equal to cos cubed theta plus 3 iota cos squared theta sine theta. Iota squared minus 3 cosine theta sine squared theta. Iota cubed minus iota sine cubed theta. So I could say cos theta plus iota sine theta to be cubed is that using the Moivre's theorem. Or I could say it's that using Pascal's triangle. So therefore, what about that and that? They're the same. Therefore, I can say cos 3 theta plus iota sine 3 theta has to be the same as cos cubed theta plus 3 iota cos squared theta sine theta minus 3 cosine theta sine squared theta minus iota sine cubed theta. And if that side is equal to that side, well then I can equate the reals and the imaginary. That's a real number, that's a real number, and that's a real number. Yes? So what can I say therefore? Well, cos 3 theta has to be equal to cos cubed theta minus 3 cos theta sine squared theta. That's equating the reals. These are the iotas. So they're the only numbers that can affect iota. So that many iotas and that many iotas has to work out to be what? Sine 3 theta iotas. So I can say sine 3 theta is equal to 3 cos squared theta sine theta minus sine cubed theta. So if I'm looking for cos 3 theta, I use this. If I'm looking for sine 3 theta, I use this. Here I want this and all cosines. How will I get rid of sine squared? Cos cubed theta minus 3 cosine theta times sine squared. 1 minus cos squared theta, which is equal to cos cubed theta, that by 1, minus 3 cosine theta, that by that, plus 3 cos cubed theta, which is 4 cos cubed theta minus 3 cosine theta. If I want all this in sines, what will that cos squared become? 1 minus sine squared theta, and then I'll end up with 3 sine theta minus 4 sine cubed. So that's your first type of identity. But that is the maths if you're looking for a sine or a cos A theta. If they asked me to get what cos 4 theta was equal to, I would start off by saying cosine theta plus iota sine theta to the 4 is equal to cos 4 theta plus iota sine 4 theta. That's by what theorem? The Moivre's theorem. And then I'd work the same thing out by what? Pascal's triangle. So what about what I get here and what I get here? They're the same. Then I can equate the reals and the imaginary. I'm going to say this for the last time. That is only if it's sine A theta or cos A theta, there is no power. If there's no power, that's the identity.